Today, we are so excited to share the details of Lavacrete construction.
This exciting, new to us building technique promises a sustainable, thermally efficient, fire-resistant, low-carbon concrete-style wall that uses scoria or lava sand.
Simply put, it goes up fast, is less labor-intensive than earth bags, needs no finishing work, and because the lava sand is a byproduct of landscaping lava rock, the material is cost-effective.
While pioneers like Paul Schwamm and others have been pushing this technology forward for the last 30 years, there's very little information online about it.
That's true. So today we're going to do our best to explain Lavacrete with help from the pros, looking at the history, materials, process, and even gorgeous examples of what can be done with this technique. Like we said, there's not much information about building with Lavacrete on the internet, so it's really hard to tell where it originated from.
If you look back, the ancient Romans used ground volcanic rock in some of their early concrete, but really the whole idea has kind of been forgotten about until the last few decades. And believe it or not, most of the development has been happening right under our noses here in Tucson, Arizona for the last 30 years. This is Paul Schwamm. He's an architect that has spent most of his career focused on designing and building sustainably. He co-founded World Geodesics with Al Miller and Buckminster Fuller in the 80s and found volcanic architecture in the 90s.
I guess where all this started was after I graduated from the University of Arizona. I had met a professor there named Al Miller, who was Buckminster Fuller's right-hand man. We started a company together, and it was through the teachings of both Al and Buckminster Fuller that I got into sustainability before sustainability was actually coined. I got to listen to the conversations between those two, which was great training. A buddy of mine in school named Randy Ewers, his father was building with scoria 10 years before I even knew it was around. Randy then continued that process, and he built a house here in Tucson, and I was involved in that. And I was just very intrigued with the fundamental power and capability of this material. It was so easy to work with, very flexible. It also had some big room for improvement. I selected the word lava actually for my business. Lava stands for lightweight aggregate vertical application concrete. That's probably what I innately was attracted to at that time. This was a vertical kind of a concrete, very playful, was relatively inexpensive, going up as walls and roofs and other things. And that's brand new gymnastics for architecture. So I wanted to bring that architecture to my design work. So I've been developing equipment for 30 years. I've built several houses along the way. I kind of build houses by accident while you're developing an industry. But that was the beginning of this, and sustainability was always my North Star.
This is Guru Das. He began learning with Paul in 2017, and his construction company, called Awareness Ranch, has continued to build with Lavacrete and other alternative building styles over the last 5 years, getting tests done for engineering and certification.
I've been really interested in experimenting with as many materials as possible because I'm really interested in building long-lasting, resilient, sustainable infrastructure. So if something has to be rebuilt over and over, it's not as sustainable as it might seem, right? Although I do love softer materials, this Lavacrete material is a hard, long-lasting material. And I think if we can build something once and it can serve a purpose for many generations, that's the goal that I'm after. I really want something that's going to have longevity for many generations. And I think this Lavacrete material does that.
So we're excited to dig in and see why Lavacrete might just be the next big alternative building technique. Let's learn why. Lavacrete is uniquely positioned as a material that we're all familiar with, concrete, but it has a number of upgrades and benefits while also being more environmentally friendly.
Scoria sand is a byproduct of screening for landscape lava rock. When crushed and sifted, you end up with a very sharp, lightweight aggregate that locks in tightly with other material.
You still need to add a binder like cement or lime, and rebar is recommended for lateral forces. However, it differs from traditional concrete in workability, application, and performance.
It took me a long time to find out why I like this stuff so much. It seemed to have all these innate qualities automatic to the material. I should say that by comparison, regular concrete is perfect for slabs, bank vaults, and bridges. But it's overkill for architecture. At the heart of lava is taking some of that strength of regular concrete and trading half of that strength for new qualities in architecture.
The material is blended in a highly aerated and fluffy way, finding the balance between strength and durability, but also increased insulation and sound absorption. It's poured much drier than concrete, so it cures faster.
There are no masonry joints, meaning fewer points of failure, and is thermally efficient, acoustically insulated, fire resistant, and termite resistant. Even better, it doesn't require additional labor like heavy compaction or vibration.
The cherry on top is that once the forms are removed, there's no finish work needed. The surface is naturally weather resistant and absolutely beautiful. This has the potential to save so much labor during the finishing stage, is one of the reasons we're really excited about Lavacrete.
Yeah, no plaster is the best plaster.
Now, we should say up front that Lavacrete is going to make more sense for you if you're near scoria or cinder sand or other volcanic-based materials. An important part of building more sustainably is reducing the transport of your material, so just keep that in mind.
Yeah, and for those of you who are like, this sounds really cool, how does it actually work? Don't worry, we're going to get into it.
The basics of working with Lavacrete are actually really simple. You just need an aggregate, a binder, some water, some forms, and reinforcement. You'll mix the aggregate, binder, and water. You'll put it into a form that has reinforcement in it.
The aggregate in this mixture is the scoria sand. Fine grain will give you a smooth finish, but you can use gravel-sized scoria, then sandblast for a pebble texture. The pieces of sand are very sharp, and this helps everything lock together when the binder is added.
For the binder, you can use Portland cement or lime, and there are pros and cons to each. Portland is easier to get, cures faster, and speeds up build times, but it's terrible for the environment and is prone to cracking over time. Lime is potentially more expensive and difficult to source and cures much slower, thereby removing the build fast benefit of Lavacrete. But long term, lime has been shown to self-heal and continually become harder over time.
At this point, lime in the Lavacrete space is just now being explored.
Right, most of the builds that are happening are permitted and engineered, and so they're requiring Portland, and also most clients don't want to wait around for that extra time for the lime to cure. They want to get the build done as quickly as possible, but we do hope that we can experiment with lime in this space because it's way more environmentally friendly than Portland.
Yeah, and it just gets better over time.
Lavacrete definitely differs from concrete in that it's mixed in a very dry and aerated and fluffy way. In fact, it gets mixed in reverse. That means the lava sand and a small amount of water are mixed first so it becomes saturated, and then the binder is added last so it can coat the aggregate. Start with 5 parts lava sand to 1 part binder and 1 part water. If you see the liquid coming to the surface when tamping, reduce the water in the mix.
Auger style or vertical shaft mixers can help make the mixing and transporting of the material easier to work with since it doesn't flow like concrete.
It's just like a wet sand mix. It's just got a light coating of binder around each grain, and then the grains touch each other once they're tamped. So it's totally different than a flowable concrete mix. And then it doesn't really exert any outward fluid pressure on the formwork. You can feel the difference just by holding it.
Once the lava sand is evenly coated with the binder, you put it in the form and lightly compress, where it sticks together and creates an incredibly strong wall.
The material is just moist enough to coat each grain with the binder, and it's not so moist that it will slump, so it'll have 0 slump. You'll be able to form a vertical wall without any sagging. But yeah, our Lavacrete gets placed in lifts that are 2 feet at a time, and we allow each section or lift to set before we place the next set of forms. We like the 2-foot dimension because it's the perfect dimension to be able to reach down into the form, tie rebar, retrieve a tool. It's not too far that we're going to be limited in our reach. These 2-foot sections are made out of a 3/4 inch plywood, And then they're stiffened with a whaler on the outside of the form. We'll also place a mason's line to give us a gauge for the straightness of the wall. And we can even use a little 1.5-inch feeler as a gauge to make sure that these walls are nice and straight. The material gets compacted with small tamps. And we're not tamping it so hard that we're crushing the material. We're tamping it so that the grains touch each other and that we fill in any potential voids. You can compact it too much, which would increase its strength, but it would decrease the amount of insulating value that the material provides. So we want to find a happy medium. So a small tamping surface with light pressure is all that's really needed. And that also ensures that our workers aren't being maxed out on their effort. The material has an insulation value that's somewhere between 0.5 and 1 per inch. That is in R value. And so a 16-inch wall is more than enough for the thermal efficiency that this material provides.
To add structural rigidity other than compression strength, a rebar cage is recommended as the walls are poured.
These rebars, these reinforcing steel bars, they provide a high tensile strength. The material has a high compressive strength on its own, but these rebars resist stretching and pulling forces, so that adds to the tensile strength of the material. Steel rebars are okay in dry conditions, but they can corrode. You can already see that there's iron oxide forming on the surface of these bars. And if you're in a moist environment, especially near the ocean, the rebar is going to be a point of failure. So in some projects like garden beds, for instance, where we know there will be moisture present, we like to use hemp rebars or tree bars. There's also a glass rebar that you can use, and then there's a basalt rebar that uses like a stone fiber. Those rebars are a more earth-friendly product, and they resist corrosion just fine. And then the placement of rebar is really important in these buildings as well. We're adhering to the Adobe code as a conservative place to start. And we're using a number 4 bar, and it's a 4-foot by 4-foot grid at the center of the wall. And then there's special rebar placements that go parallel to the window and door openings. So here you can see we've got 2 number 5 bars parallel to the window opening on either side and up above the window. And then for extra reinforcement, we've got diagonal number 5 bars that extend 2 feet from each corner.
You don't really need fancy tools to build with Lavacrete. Other than a mixer that can handle that dry mix, simple shovels, wheelbarrows, rebar cutting and tying tools, and scaffoldings are really all you need to get going. So as you can see, you don't need much to create thermally efficient, highly compressive, naturally beautiful walls with Lavacrete.
But there are a few additional core techniques for foundation, doors, and window openings.
So even though Lavacrete is a lot lighter than normal concrete, you still need substantial footings to hold the building up. In the case of a 12-inch wall, a 2-foot deep and 16-inch wide footing is just right. We'll put 3 parallel bars of number 4 rebar running across that footing, and then we'll also have uprights that poke up through the footing into the main wall section at every 4 feet. So in order to make the lifts go in seamlessly without too much downtime, we place our corners around windows and doors before we put any of the formwork in between. At all of our corners and doorways and windows, we also have extra reinforcing bars that run vertically, and there are also continuous bent rebars that turn the corner. The doorways, we're gonna stop that 4-foot grid of rebar in the opening, and we're gonna run 2 parallel bars within 12 inches of either side of the opening, but leaving the opening free of any rebar. This building format also allows us to predetermine where our electrical is going to be placed, and so we'll mark the outside of the form to show us where an electric box will be mounted, and we mount the box directly to the formwork, and then conduits run up the wall to the top of the wall.
Lavacrete is super DIY friendly, but can easily scale up to engineered code-compliant residential and commercial structures.
Let's see what it's actually like to be in one.
there's all kinds of things that you can do with this Lavacrete. If you want to cast a feature, you just put a piece of wood in there. And I don't know if you noticed, over above in the top, in the middle of the house, there's a feather. You can show people that you can do all kinds of things with the flexibility of the casting of the Lavacrete. All you have to do is make a wooden template, put it in a wall, and cast the Lavacrete around it. We've been in here 15 years now, and there has been no maintenance on these walls whatsoever. Living in there has been a real pleasure.
I'm standing next to my Lavacrete Hexagon studio here. The original idea for this Lavacrete studio was to do a rammed earth studio. The architect came across Paul Schwam and came across this Lavacrete material. Lavacrete had a lot of the same qualities, if you'd like, as rammed earth, but also we can make the building a little bit cheaper. And so I took a chance and built myself this Lavacrete, and we've never looked back. We have since built so many Lavacrete projects, and we love that, Paul wants us to continue building this. We're proud that we're making him proud. The whole thing has been really the connections it creates too, and meeting people who are like-minded, who also want to build a natural building. We have wonderful community, people creating community, and that's what this has really created. It's just the start of something beautiful and exciting right here.
And I'm imagining that you could do multi-story commercial buildings, multi-family housing, building small communities out of it.
There are new limitations that an architect can take advantage of with this material that I don't even completely realize at this point. But I can tell you that the creation process of lava isn't done, and there's a lot more to go in the world of 3D architecture, and this is just the beginning.
So you may be asking, John and Ashley, why are you talking about Lavacrete? Like, you haven't built with it. Aren't you the Hyper-W Earthbag people?
We are, but we got so excited about this Lavacrete technology that we decided to do the Lavacrete Utility Lodge here on our property as a workshop with the experts.
And we just want to make sure there's information on the internet about this building technique.
Yeah, it's so cool. People need to know about it.
For the workshop, Guru Das is running the build, and Paul will be on site for a few days answering questions and sharing his stories. The actual project is a 12 by 16 Lavacrete utility lodge that will house the solar gear and water system for the Hyper Adobe Roundhouse, plus a full guest bathroom with a shower.
Now, the goal with this building is to make it as thermally efficient as possible. We'll have our water in there and our batteries, so we don't want it to get too hot or too cold.
So this is all part of the experiment for us, is we want to see how thermally efficient it's going to be, just as is.
Yeah.
During this 6-day workshop, we will build all of the walls for the Lavacrete building, but we'll also be covering how to build the forms for the corners, lifts, doors, and windows, how to mix the material, and plan for conduit and utilities.
So this is all happening April 6th through 11th here on our property. You can camp here, stay here. We will feed you breakfast and lunch every day, and the cost is $1,000 per person.
This is a unique opportunity to learn an exciting new alternative building technique from the experts, everything you would need to know to start your own Lavacrete project.
Spots are filling up fast, so if you want to get your hands on this Lavacrete technique and learn from the pros, you can go to tinyshinyhome.com/events to sign up now.
Leading up to the workshop, we'll be sharing our process of prepping the foundation, pouring the pad, and trenching all of the utilities that will connect from this building to our Hyper Adobe Roundhouse, our water tank, our solar panel array, and our septic system.
There's so much to do and so little time. Are we going to make it?
Well, I guess you'll just have to keep watching to find out. Yeah?
Yeah.
See you soon.